So hello everyone again. Today we will start a new chapter called as ray optics and optical instruments. So let's start. Let's see what is in this lecture. So basically our optics is divided into two parts. One is ray optics, one is wave optics. So in ray optics, the theory which is considered is that they are considered as the discrete particles, and then we try to assume or we try to prove different laws of reflection and refraction. In this chapter we also understand some optical instruments also. We understand about spherical mirrors, spherical lenses, etc. There is another chapter called as wave optics. In that chapter we understood and understand some other concepts, such as why there has to be a need to understand the complete concept of light using wave theory, why it is considered as wave theory, why an electromagnetic wave has been considered there, and so on. These all things are being dealt in that chapter called as wave optics. Today we will start with new chapter called as ray optics and optical instruments. So I am Sameer Lavankar. Let's begin our first discussion. Okay, so let's not start with the course outline. I will just start with the introduction for now. So let me start with the introduction, and as we move on I will try to explain everything which we have dealt apart. Okay. So the introduction to the ray optics and optical instruments. Okay. So as you can see, if already this is a basic concept which everyone knows, that a ray of light always passes or always goes through a straight line. Now nature has endowed the human eye or retina with a sensitivity to detect electromagnetic waves within a small range of the electromagnetic spectrum. So let us suppose that this is the complete range of electromagnetic spectrum. Only the human eye can retain this much. What is that range? We will try to understand. So the electromagnetic radiation belonging to this region of the spectrum, what is that? Wavelength about 400 to 750 nanometers. So there is called as 400 nanometers here, and there is something 750 nanometers here, which is called as light. So the region this is called as light. Why it is called as light? Because this is only the part of the radiation whichever eye can see, whichever eye can bear. Okay. So it is mainly through light and the sense of vision that we know and interpret the world around us. Quite evident, even anything which passes through our light, only we can then attain it, we can observe it. There is a man standing, there is a video camera standing, there is a watch standing, or a person, animal, anything which we view, whichever eyes can observe, we can only interpret the world around us through that. So it is mainly through light and the sense of vision that we know and interpret the world around us. Now there are first two things that we can intuitively mention about light from common experience, or which you already studied in the previous chapters or previous classes. So what are those? The first is that it travels with an enormous speed. The speed is very fast of travel of light from one part to another part, and second is that it travels in a straight line. So these two things, this is the basic concept which everyone knows, that first of all it has a very high speed, and second is that it travels in a straight line. How it travels in a straight line? As you can see, that this are all the lights which travel in a straight line. Okay. The next part. So now when the research was being done, when the research was being analyzed, when different particles were being analyzed, when the light was being analyzed even from sun, or let us say from any artificial source or etc., it took some time for people to realize that the speed of light is finite and measurable. It is not infinite. So first of all, in previous researches or in previous studies, very large dated back, it was understood that speed of light is infinite. It cannot be measured. But when the more research was being done, it was being found that it is a very finite value. Though it is large, it is a finite value. What was the value? The presently accepted value in vacuum. Please make sure it is in vacuum, not in any medium. In vacuum is C is equal to 2.99792,458 into 10 to the power 8 meter per second. Or for general purposes, for general calculations, we may take it as C is equal to 3 into 10 to the power 8 meter per second. So this is the speed of light. The thing which previously was being understood as travelling with an enormous speed, we got its value, and which was equal to 3 into 10 to the power 8 meter per second. Okay. So now we know the value. Now next thing is, so the speed of light in vacuum is the highest speed attainable in nature. Yes. So please remember this portion, that the value of C keeps on decreasing with the different media. It can be less, it can't be greater than 2.99792458 into 10 to the power 8 meter per second. The maximum it can attain is in vacuum, which is this value. Okay. This thing is also been understood. The intuitive notion that light travels in a straight line seems to contradict what we have learned in previous chapters, that light is an electromagnetic wave of wavelength belonging to the visible part of the spectrum. So, basically what they try to say is there are some of the things, there are some of the intuitions, there are some of the observations which a wave theory of particle can only attain, or a wave theory particle can only understand, but there are some portions, there are some particles, there are some ideas which only needs or which can only be understood even if we consider it as discrete particles. So, why do we consider that? What are those diffraction ideas which we understand using wave theory? So, just put them aside for now, let us study this ray optics only, and let us move on with this discussion only, that why do we understand it as electromagnetic wave, but here we are understanding it as discrete particle. Okay. So, how to reconcile these two facts as in wave theory and particle theory of light? So, the answer is that the wavelength of light is very small, as we previously also understood, it is in the range of 400 nanometers to 750 nanometers. So, this is that range. Okay. The answer is that the wavelength of light is very small compared to the size of ordinary object that we encounter commonly. Quite evident that, because let us suppose even if we take the smallest to smallest thing, these are in the order of centimeters or let us say millimeters. Even millimeters is very large than nanometers, because millimeter is in the range of, so if I write millimeter is 10 to the power minus 3 meters and nanometer is 10 to the power minus 9 meters. As you can see, the order is 10 to the power 6 times greater. So, because there is a range or there is an order, high range of order difference between the wavelength of light and the object particles. So, what happens is, the answer is that the wavelength of light is very small compared to the size of ordinary objects that we encounter commonly, generally of the order of a few centimeter or larger. So, in this situation, a light wave can be considered to travel from one point to another along a straight line joining them. So, even if we consider like this, and even if we hit, the value is so small, these electromagnetic waves moving are so small that this can be considered as a straight line only. So, that is the explanation being dealt here. But there are some phenomena which are observed in our natural surroundings which can only be observed or which can only be proved using wave theory of light. Those concepts are already dealt in wave optics, you can just refer those lectures, but for now you can understand this concept that there are majorly at least 90% of the things can be understood using your discrete particle or discrete particle theory of light, but there are some portions such as diffraction, polarization, etc., that can only be understood if we consider light as wave theory. Okay. But here for just understanding, but at why can we consider this thing as Descartes theory or the discrete particle theory of light? It can be understood because the wavelength is very small than the object to be observed. Therefore, we can understand that the small sinusoidal waves would be formed there, but these are so much small that we can consider the complete as a straight line only. So, that is the thing to be understood here. Okay. So, in this situation, a light wave can be considered to travel from one point to another along a straight line joining them. So, along a straight line, so let us say this is the one point, this is the one point, this is the straight line which is joining them. Okay. So, this thing has also been understood here. Next, the path is called a ray of light. Quite evident, what is a ray of light? So, you may know this concept in your mathematics. So, there is something called as line, so which starts, which is a no end. So, it has no end on both the directions, this is called as line. Then there is something called as line segment. So, line segment has both ends, and there is something called as ray. So, ray has a one end and there is no end on either or on one of the direction. So, this is called as line, this is called as line, this is called as line segment, and this is called as ray. So, quite evident why is a light called as a ray of light, not a line of light, not a line segment of light, because on one point there is a source, on one point there is source, and on the other point the light just goes on and goes on and goes on. Okay. So, that is the reason why we call it as ray of light. So, a path is called a ray of light and a bundle of such rays constitutes a beam of light, quite evident. So, as you can see, so this is a ray of light and this is nothing but a beam of light. Okay. So, this thing has been done. Let us move on. So, in this chapter we consider the phenomena of reflection, refraction and dispersion of light using the ray picture of light. So, basically we use discrete particle theory to understand basic laws of light, that is reflection, refraction and dispersion of light. Okay. Let us move on. So, using the basic laws of reflection and refraction, we shall study the image formation by plane and spherical reflecting and refracting surfaces. We then go on to describe the construction and working of some important optical instruments, including the human eye. So, these all things will be considered, these all things will be explained in this chapter in detail. So, just sit back and view every concept very clearly. So, basically as far as these reflecting surfaces are being considered, so spherical mirrors and spherical lenses, so basically convex lens, concave mirror and convex mirror will be dealt apart here in this lecture. So, this concept, this complete chapter is completely based on your sign conventions. So, these sign conventions have to be taken with very much care, because even if you change one thing, a complete equation can change and your answers will be wrong. So, for this concept, for this complete ray optic, just look over the signs which you are putting when you are deriving the questions or when you are doing for the solutions, analyzing the questions and so on. So, please, just my suggestion would be that for the complete ray optic chapter, just look on when you are trying to put the value of u is equal to minus 20 or plus 20 or v as minus 20 or plus 20. So, please look over here, rest all everything is easy in this chapter, there is nothing hard, only the concept which need to be understood is the sign convention. Okay. So, now let us move on to the next concept, that is reflection of light by spherical mirrors. So, quite evident as the name says, spherical mirrors. So, why it is called as spherical mirrors? So, basically let us suppose this is a complete sphere. Now, what we do is we cut a portion like this or we cut a portion like this. So, basically these are two types of mirrors. So, there is something called as this mirror which is having, and there is something called as this mirror. So, these are two types of mirrors. So, why it is called spherical mirror? Because these mirrors are a part of a complete sphere, that is why. Okay. So, let us move on. So, what is written here, let us see. So, we are familiar with the laws of reflection, quite evident. What are these laws of reflection are being explained in the subsequent line only. So, first is that the angle of reflection. What is the angle of reflection? Reflection is the angle between the reflected ray, as you can see this is the reflected ray, and the normal to the reflecting surface. So, this is the normal to the reflecting surface, quite evident, this is the normal to the reflecting surface or the mirror. So, it can be either mirror or either it can be reflecting surface. So, reflecting surface is denoted like this. Okay. Equals the angle of incidence. What is the angle of incidence? Angle of incidence is the angle between the incident ray and the normal. Okay. So, quite evident, very easy concept. So, it is nothing but angle I is equal to angle R. So, this is the law of reflection. Also, that the incident ray, reflected ray and the normal to the reflecting surface at the point of incidence lie in the same plane. So, it can be understood like this, that this complete three lines, these all three lines are always in a straight line. So, even if we take a cardboard, we put it on that portion. So, incident ray and the reflected ray can come and in the same plane, in the plane of the cardboard. So, this is, and also the normal. So, basically the incident ray, the normal ray and the reflected ray are all lying in the same plane. So, if we take an example of a cardboard, we just put the cardboard. So, basically that can be considered as a plane. So, and if the incident ray is along the cardboard, normal is also along the cardboard and the reflected ray is also along the cardboard only. So, that is the second law of reflection. Okay, so, these were the two laws of reflection. Let us move on. So, what is written here next is that these laws are valid at each point on any reflecting surface, whether plane or curved. So, even if it is plane, so what does it mean by plane? Plane just means that R or radius of curvature is nothing but infinity, and what is meaning by curved surface? Basically radius is equal to finite. What is this radius I am talking about here? It is just the radius of your complete spherical mirror. So, let us suppose this is the spherical mirror we are talking about. Let us suppose this is the spherical mirror we are talking about. So, this is that radius being talked about here. So, basically as you can quite understand that if this R is very large, or it is if considered in ideal situation is equal to infinite, then this spherical surface will change into a one plane surface. So, if the surface is, or if the radius is infinity, then it can be considered as a plane, or it can be considered as a plane mirror, and if the radius is finite, then it can be considered as a curved mirror. Okay, so this thing has been explained. Next is, however, we shall restrict our discussion to the special case of curved surfaces, that is spherical surfaces. So, for now, even when we deal with the mirror equation, lens equation or anything apart or in the subsequent slides, we are only considering sort of curved surfaces which are spherical mirrors, which are a part of spherical mirrors only. So, that is only being understood or dealt in this chapter. Okay. However, we shall restrict our discussion to the special case of curved surfaces, that is spherical surfaces. The normal in this case is to be taken as normal to the tangent to surface at the point of incidence. So, what does it try to understand here? Let me try to explain. So, let us suppose this is the spherical mirror being talked about here. Let us suppose we are talking about the point this. So, first of all, we make a tangent at this portion. So, let us suppose this is the tangent. Let us suppose this is the tangent we talked about here, and the normal in this case is to be taken as normal to the tangent to surface at the point of incidence. Let us suppose this is the point of incidence. So, there is a point of incidence acting like this. Now, what we do is we will just make a perpendicular to this portion, we will just make a perpendicular to our tangent. That tangent surprisingly or coincidentally will pass through the center only. So, this is that 90-degree portion. This is your normal here. What it is normal to, it is normal to the tangent at the point of incidence. Therefore, the angle of incidence will be this, and there similarly using the laws of reflection we can find out that the angle of reflection will be this. Hence, I is equal to IR. Okay. So, the normal in this case is to be taken as normal to the tangent to surface at the point of incidence, that is the normal is along the radius, quite evident as you can see the normal, just let me change the color. So, as you can see the normal is along the radius. So, this is along the radius, as you can see the direction of normal and the radius are in the same direction or along the same, if we say it is as a vector, it is along the same vector. Okay. Normal is along the radius, the line joining the center of curvature. So, this is the center of curvature for you, center of curvature, let me write it as COC of the mirror to the point of incidence, and this is the point of incidence for you, this is the point of incidence. Okay. So, this thing has also been explained. Next, the line joining the next is we have already studied that the geometric center of a spherical mirror is called its pole, while that of a spherical lens is called its optical center. So, just this is just the theory part, you just need to remember that what is the center of a spherical mirror called, it is called as a pole, and what is the center of a spherical lens called, it is called as optical center, because these all things will be dealt in when we try to understand, when we try to analyze the ray optics questions. So, just remember theory part that the geometric center of a spherical mirror is called its pole and that of a spherical lens is called its optical center. Okay, let us move on. So, next thing is that the line joining the pole and the center of curvature. So, there may be a pole here. Let us suppose I make a spherical mirror like this. Let us suppose this to be the pole, let us suppose this to be the center of curvature. So, basically let us write COC. So, basically a line joining these both, it can be even extended like this, is known as the principal axis. So, this is nothing but called as principal axis. The principal axis, so this is in the case of spherical lenses. Similarly, in the case of principal axis again is the line joining the optical center with its principal focus, as you will see later. So, it is nothing but, so line between pole and center of curvature, and it is a line between optical center and principal focus. These all things will be very easy to understand or very easy to memorize when you will do the questions, but for now if for a theory portion you just need to remember that what is principal axis, it is nothing but a line which is joining the pole and the center of curvature of the spherical mirror, and for lens it is that optical, the line joining the optical center and the principal focus. Okay. So, these all things are being just the definition parts. So, let me stop it here, let me stop this part here only. In the next lecture we will start with the discussions along this portion, and I will try to make you understand what are the sign conventions which you need to understand. Okay. So, let me stop it here. So, thank you.